Have you ever just looked at your wallet and wondered, why doesn't this money go as far as it used to? Well, today, we're going to crack open a formula that's over a century old, but it tried to explain exactly that. It's one of the most fundamental ideas in all of economics, and believe it or not, it really just boils down to four simple letters.
Just think about that for a second. What if all the headaches, all the news reports, all the complexity of inflation could be explained with one single, clean equation? That's the exact puzzle that the brilliant economist Irving Fisher tried to solve way back in the early 1900s. And the answer he came up with? Well, it's still being taught in every first-year economics class around the world.
And there it is, the equation of exchange, MV equals PT. I know, it looks like something you'd see in a high school math class, right? But these four little letters, M, V, P, and T, they form the absolute bedrock of how we think about the connection between money and prices. So, let's break down what each one actually means.
Okay, first up, we've got M from money supply. This one's pretty easy to get your head around. It's basically all the cash, all the coins, all the money sitting in bank accounts that's sloshing around in an economy. You can think of it as the total pool of money that's available for people to spend. And in Fisher's original idea, this is a number that the central bank, like the RBI here in India, can pretty much control.
Next, we have V for velocity. Now this is a really cool idea. It's not just about how much money there is, but how fast that money is moving. Velocity is the number of times a single rupee bill, on average, gets used in a year. Is that rupee just sitting under a mattress, or is it flying from a shopkeeper to a supplier to an employee and so on? A high velocity means money is really zipping through the economy.
Then we get to P for the price level. This is the one we all feel in our day-to-day lives, right? It's the average price of everything being sold, from your morning chai to a brand new car. When P goes up, that's inflation. Your money buys less. When it goes down, that's deflation. Ultimately, this is the thing we're trying to figure out.
And last but not least, we have T for transactions. This just represents the total amount of stuff being bought and sold. It's the grand total of every single good and service that changes hands. Every phone sold, every meal delivered, every doctor's appointment. It's the sheer volume of economic activity.
So when you put it all together, you get MV equals PT. And the logic here is, well, it's almost beautiful in its simplicity. On the left side, MV is the total amount of money spent in the economy. That's the money supply multiplied by how many times each rupee is spent. And on the right side, PT is the total value of everything that was sold. That's the number of transactions times their average price. It's not just a theory, it's an identity. It has to be true. The amount of money spent has to equal the value of what was bought. It's a perfectly balanced scale.
Okay, that's the theory part done. But to really see how this works, let's make it real. Let's shrink down the whole complicated economy into one tiny imaginary village.
All right, so in our village, there's a total of 1,000 rupees. That's our M. And we know that each of those rupees gets spent about 5 times a year. That's our V. So, if you do the math, the total spending in the village, our MV, is 5,000 rupees. Now, in that same year, the village workshops and farms produce a total of 100 things to sell. That's our T. The big question is, what's the average price of each one of those things? Well, using Fisher's equation, the math is super simple. You've got 5,000 rupees in total spending, and that money is chasing 100 goods. So you divide 5,000 by 100, and you get an average price, RP, of 50 rupees per good. See, everything is in perfect balance.
But what happens if we mess with one of the numbers? Let's say the village council decides, hey, let's get this economy going, and they print a bunch of new money and give it to everyone.
So now, the money supply, M, has doubled. There are 2,000 rupees in the village instead of 1,000. But, and this is the absolutely crucial part, the village hasn't magically built more factories or grown more crops overnight. The number of goods available to buy, RT, is still exactly the same, 100 units. Everyone is richer on paper, but there's no more stuff to buy.
And this is where you see the magic, or the danger of Fisher's equation. With a money supply of 2,000 rupees and a velocity that's still 5, the total spending now shoots up to 10,000 rupees. But since there are still only those 100 goods to spend it on, the average price has to rise. It goes up to 100 rupees per good. The money supply doubled, and boom, prices doubled too. This is inflation in its purest, simplest form. And this brings us to that classic phrase I'm sure you've heard before because it perfectly sums up what just happened in our little village. Too much money chasing too few goods. When the amount of cash grows faster than the amount of stuff you can buy with it, prices have pretty much nowhere to go but up.
Okay, I know what you're thinking. That village example makes it seem almost laughably simple. But the real world is a lot more chaotic, right? Fisher's theory is so clean because it leans on a few really big assumptions, and those assumptions, well, they don't always hold up in the real world. So Fisher's whole beautiful equation kind of depends on V, velocity, and T, transactions, being pretty stable and predictable. But are they? In the real world, the velocity of money can swing all over the place. When people feel good about the economy, they spend money like crazy, and V goes up. But in a recession, people get scared, they hoard their cash, and velocity just tanks. And T, the amount of stuff being produced, is obviously not constant. That's what economic growth or recession is all about. And then the legendary economist John Maynard Keynes came along and pointed out another huge flaw. People don't always spend extra money. Sometimes, especially when they're worried, they just save it. All of these human behaviors really complicate Fisher's simple picture.
So, if the assumptions are a bit shaky, if the real world is so messy, why on earth are we still talking about this equation 100 years later? Well, it's because even with its simplicity, the core logic of MVPT is still an incredibly powerful way to think about how an economy works.
I mean, this equation is basically the DNA of modern monetary policy. It's the logic that fuels all those intense debates about things like quantitative easing, where central banks pump huge amounts of M into the system. It's also the absolute clearest model for understanding the tragedy of hyperinflation in places like Zimbabwe or Venezuela. Textbook examples of what happens when a government prints way too much money. And you know what? In our world of instant digital payments, that idea of velocity is actually more important than ever. So even with its flaws, this equation is still the starting point for any serious discussion about money and inflation.
Which leaves us with one final and really important question. If the basic math is this straightforward, why is controlling inflation so incredibly difficult in the real world? And I think the answer reminds us that while the equation itself is neat and tidy, the human behavior that drives V and T, our confidence, our fear, our choices, is anything but. And that right there is the puzzle that keeps economists up at night.